Hello. This video is an advanced look at the topic of file name substitution using wildcards in the Linux shell. Specifically, I will show you how to distinguish between regular files and directories in wildcard matching and how to match file names recursively inside subdirectories. I will also introduce the find command. Shell file name expansion, also called globbing, is a great feature that allows us to match multiple file names using simple meta characters such as asterisk, question mark, and square brackets. These meta characters match both regular file names as well as directory names, and we use them within a specific directory location. Our ability to distinguish between regular files and directories is limited with shell globbing. Let me illustrate that with an example. Here, my present working directory has a mix of regular files and directories. Now I will use an asterisk glob to print only file names that start with a lowercase a. As expected, both regular files as well as one directory were matched. If I want to match only directories, I can add a slash at the end of the glob, and that works okay. This technique can be useful in some situations. Unfortunately, there is no simple way to do the opposite action to match only regular files while excluding directories. The second limitation of shell globbing stems from the fact that each wildcard pattern normally applies to a specific location, either present working directory or another location specified as a path name. Admittedly, this is what we want in most cases, but it would be nice to have an option to match across subdirectories recursively. Let's have a look at my file system structure again, this time in more detail. Notice that there are file names starting with A inside apples and pairs directories, yet they were not matched earlier. Current version of the Linux shell does not have a straightforward way to wildcard match file names recursively inside subdirectories. If we want to match file names recursively, we rely on the find command. In a most basic scenario, we can use find command to search for a specific file name without wildcards, for example, Ambrosia. This command has 4 tokens: find command, start location to be searched, which in this case is my present working directory, the search type, and finally the file name. You can provide more than one search location in form of directory names or path names, or you can skip that token if you are searching in your present working directory, which is the default. Here's the command again, this time without an explicit search location. Results are the same, but a shorter command is more elegant in my opinion. The -name option accepts expressions that contain wildcard meta characters the same way as in the shell. However, meta characters used here are processed internally by the find command. This is why it is very important that any find command search pattern that contains meta characters is quoted to prevent the shell from expanding it before the find command runs. Otherwise, the shell may expand the wildcard expression with file names in present working directory, effectively breaking it. Here's an example which will search present directory for file names that start with lowercase letter c. Note the quotes around the wildcard expression. Find results are shown as path names. For matches in present working directory, find command prefixes their names with // to make the results easier to process later if file names found are unusual, for example, when they start with a dash. I will talk about processing of search results in a few moments. It is worth noting that, as with the Linux shell in general, find command matches are case sensitive. You can use the iname option if you want the search to be case insensitive. This modified command also found the Crispin file name, which starts with capital C. By default, find command provides matches including contents of subdirectories, but we have control through the -max depth option as to how deep the find command goes. Max depth option needs to be placed before the -name option. As an example, setting max depth to 1 will exclude all subdirectories below the starting point. As I mentioned earlier, we can provide one or more starting points as an additional parameter after the command name if we want to search outside of current directory. Here's a command which will search my documents and downloads directories for any PDF files. As it happens, documents and downloads have similar names which start with capital D-O. With that in mind, I can shorten the above command by using a do*glob to match both of these names. Unlike the search pattern, which needs to be quoted to protect it from shell expansion, this pattern must not be quoted so shell can expand it to matching directory names. As I explained a few moments ago, standard wildcard matching can come back with a mix of regular files and directories, while in specific cases, we may want only regular files or only directories. The find command has a -type option, which allows us to limit the search to specific file types. For example, I can modify one of the previous searches to only look for directories, or only search for regular files. Something like this cannot be easily done with plain wildcards alone, but works very well with the find command. Let's have a look now at the search results. The find command provides its output as a list of path names printed to the terminal. This may be all that you want, but sometimes you may need to perform an action on the matching files. We have the option to tell the find command to run a specific command for each of the matched file names by adding the -exec option followed by a target command. Exec command can be any valid shell command, and we can use a pair of curly braces as a placeholder for the matching file name. For example, I will modify the previous command and instruct the find command to copy matching files into TMP directory. The curly brace placeholder will be dynamically replaced with the found file name. The semicolon marks the end of the exec command. The semicolon character is special to the shell, so it needs to be quoted, otherwise the shell will intercept it and break the find command. The command provided is executed one time for each of the matches, and the curly braces can be used more than once in the exec command if needed. For example, here's the output of an echo command. This time, the echo command has executed 5 times, adding its default new line at the end of each line of output. We have the option to execute the command once, with all matching file names used within one command. The only change in such case is replacing the semicolon with a plus character. The plus does not need to be quoted as it is not special to the shell. With this syntax, the curly braces represent all matches as a space-separated list, and curly braces here can only be used once if the plus character is used. The second method may not be compatible with all commands, as the matching file list must be placed at the end of command, or in some cases, you may need to modify default command syntax. For example, normal CP command syntax will not work. With the plus sign used, curly braces must be at the end of the command. You can overcome that by using the -t option available with CP and MV command for that matter, which allows us to specify the target directory before the sources. The -v verbose CP option documents the operation one line at a time, but you can take my word for it that the CP command ran here only once, resulting in a more efficient process. I strongly suggest to have a multi-step approach with the find command if you are using the exec option, at least until you become proficient. Run a plain find command first, just to display the results, and only then add the exec option for a second run. You will make fewer mistakes that way, especially with exec commands that make changes to the file system. Please give this video a thumbs up if you found it useful, and subscribe to my channel if you want more videos like that. Thank you for watching.